Hello and welcome to this Pandas Challenge, day 26 of 30. My name is Valentine and I'll be your instructor. In this workshop or in this video, we are going to be going through another set of Pandas library challenges that will allow us to be able to practice and acquire or even just feel more confident using the Pandas library for data manipulation. So let's get started. The first thing that you need to do is to visit the description section of this video and click on the practice resource link that should take you to a page that looks like what you're seeing on your screen. Then click on the sample practice workbook. Once you click on that workbook, you'll need to sign in. Just sign in or sign up if you haven't. And then when you get to have already signed in, you can click on the continue learning link that should take you to now the actual page that will contain the sample practice workbook, and then we can continue. All right, so once you get there, once you finally get the link to the notebook that we are going to be using, you'll get the notebook itself, which is what you're seeing here. And then you can once you get here, you can make a copy of this sample notebook. So by going to File, then save a copy in Drive, which should save a copy in your Google Drive, and it will open that copy in a new tab. You can close down the original copy. Once you have done that, then we should be good to go. I'm going to be using the practice notebook, which is just similar to the sample notebook. The only thing is that the sample notebook has fewer challenges, and the practice notebook is available to Afterwork members who've signed up for just being able to get new content and all the content on our platform. So so it will be similar to just the sample notebook, the practice notebook that is, and to just have more challenges, and there'll also be a solution notebook for those Afterwork members to verify their solutions. Right, so once we get here, once you've saved a copy, we can get started by running the first code cell, which should import the Pandas library that we can be able to use for data manipulation, analysis, etc. So what we have done here, we've used the import keyword pandas SPD, and in any instance where you see PD in your code, we are going to be referencing the pandas data frame. All right, the first concept, selecting multiple rows with iLock. In some situations, we might want to filter for data using an efficient technique, and we might want to again also filter for data more specifically using what would be called indexes. So in a pandas data frame, that's a tabular structure that we load data into. So this is the tabular structure this is a data frame. So we get our data set, which contains information about e-commerce products. In this data frame, the values on the far left are actually part of what is called the index column. So we can use that index column values, which are just unique values that represent the records in that data frame. We can use that to select for the records that we want, if we of course know the indexes for those records. So for example, if we have index 2, 5, and 8, we can be able to have those indexes saved in a Python list, store that in a variable, then pass that variable to the iLock method, which should be able to filter for those records with those indexes. So so that's what we got. We've got records with index 2, 5, and 8 as shown here. All right, so pause the video and then work on the challenge. In some other situations, we might want to insert new rows into a pandas data frame. So for example, if we maybe wanted to, assuming that we wanted to create a machine learning model, and then use that model, which is just basically a program that learns from historical data, then use that model to make some prediction. It could be just one record. Then we can insert that record into your pandas data frame as shown using the technique that we have here. So initially, assuming that we had this particular data set that we had originally, this is a new data set that we have, and we wanted to create a new row and insert it to merge it into this data frame, we can decide to create that new row and put it in a pandas data frame using pd.d data frame function. And as you can see here, what we have here is a Python list, but it contains a dictionary. So It's just one list that contains a dictionary, and that dictionary contains key values. So we have multiple key value pairs, but they would represent the column name as well as the column value that we want for that particular column. So assuming that we have this new piece of data, we transform it into a data frame, then we merge that data frame in with the other original data frame. I'm using the concat function, which generally would take in the two data frames, as well as just specify the definition of just ignoring the index column. So we don't want to also include another index column from this new data frame that we created here. We just want to merge both data frames. And yeah, and that's it. We end up just getting another data frame that contains new records. So if I do tail, if I do not head, maybe just tail, df tail, I want to see whether I can be able to preview this 1076 here. So tail, if I run it here, I should be able to see that we have 1076, which is now this record that we have here. All right, pause the video and then work on the challenge. All right, moving on. So in some other situations where we are answering research questions, we might need to filter for data, and there are many techniques, but one of the easiest techniques, I would say, from my perspective, to be able to perform filtering would be querying using the query method. So we can use the query method with a condition or multiple conditions depending on the complexity of the research problem. So if we wanted maybe to use the query method to filter for records from this particular data frame that contains, again, products information about e-commerce data, we can decide to use a query method as shown, and inside it we define the conditions. So the first condition, category, we want to query for data for records which have a category apparel, and price greater than 50, that's a price column, and also stock greater than 50, and then that will give us the queried data. All right, okay, all right, pause the video and then work on the challenge. Right, moving on, we might want to create dynamic queries. So still using the query method, we might want maybe to have variables inside the conditions that we see here, inside the string. So how are we able to do that? So I'm assuming that we had this particular data set that contains e-commerce products, and we wanted to query for records with certain conditions, but we want to define now maybe, yes, for the price column, we wanted to have minimum price, which is a variable that we have set outside. So which is what we have here. The same case with max price and min rating. Then in such a situation, we can be able to define our variables still using now, still inside the dynamic queries, as you can see here. So we use an @ sign to before now the variable name that we want to reference. So for price column, the minimum price is that. For price, again, for max price is that. The rating, minimum rating for that. All right. Around that, you can play around with the numbers, just try to understand what's happening, then we can continue. In some other situations, we might want to use the index column. We might want to compare the index column, maybe retrieve values that contain certain indexes, more like what we did for the iloc method in the first concept. But here we might want to use not iloc for filtering, but now query method. So what we would need to do, assuming that we had this data set, which I had not loaded it, but I can reload it again, df.head. Let me remove this. So if we have this data set, which contains e-commerce products information, so and the first thing that we might want to do is to set maybe the product ID We could still actually query using just these values that we have here, but we can set the index column to be product ID using the set index function as shown here. And then once we do that, we can now specify our query, then dynamic query, where we specify the index column, which would be represented by index equal to product ID, which is the value that we have here, and we display the data at the end. All right, pause the video and then work on the challenge. In some other situations, we might want to combine the query method with the assign method. So assign method allows us to create a new column. So for example, if again we had this data set that contains e-commerce products information, we might want to create a new column called high price to represent whether the record is has a high price, and we define that using a condition like high price with a condition. So previously, like for example, filtered data, e-commerce data. Okay, well, filtered data would be now based off this condition where price is greater than 50. If a record has price greater than 50, we then would want to price that as high or as yes. So for the new column, which is high price, its value would be yes. And that's just what we would want. And yeah, and we display the filter data. So we're just chaining two values there. And you'll note that the filter data, it will just contain just records with high price greater than 50. The original data frame will just remain as it is. We haven't done anything to e-commerce data frame. All right, pause the video and then work on the challenge. So in some other situations, we might want to perform multiple operations like what we have done here, which we actually used the query method and also we used the assign method. And that's called chaining. And that's what we're going to learn in this new section. So assuming we had this data set again, let me just paste it outside, df.head. Assuming that we had this data set that contains the following information, and we wanted to perform filtering, but now having applied multiple operations. So for example, we can query for data that has category as apparel, and then this / that you see here, if we want to define now the next, if we don't want our code to just go horizontal, we could decide to not go, like, to be at horizontal format. If we realize that having maybe this doesn't look nice, like, you can see what we are seeing here. Let me just, if you look at this code, it does not look really appealing because it's a one line, the multiple operations. So we can decide to have that each and every operation in its own line, and then specify that this particular next line is actually a continuation of where this particular line ends. We then would use / to define that once we have pushed the code to the next line as shown. The same case is shown. And you cannot just put that next line in between, let's say, the word alloc and then put a / That won't work. It has to be distinct. Like, you have to define your operation separately. So in full. So here we are performing our filtering, then we are sorting, and then we are sorting in this line, and then we are selecting the columns that we want using the log method. That's basically what we're doing in this particular case. We're just chaining. When we have multiple operations together, we are just basically chaining. So we are doing this first, then this secondly, then this thirdly, and then we save that in the result variable and display the final result. Awesome. Pause the video and then work on the challenge. All right, moving on. So here, as you can see, we have multiple operations, but in some situations we might have multiple functions. So if we had, let's say, multiple functions in our code that we want to apply them together, instead of running them like clean data, normalize price, you can apply them to a Pandas data frame in a chaining way, like what we have done. So we can define, let's say, our first function, which just cleans data. So it's called clean data function, and normalize, and then our second function, which is normalize price operation. So once we define those, we can then, once we have defined those, we can then decide to, this is actually what we have defined. We actually defined that. Then we can load our data, the data that we will transform, and apply now those two functions to that particular data frame. So instead of using the apply function or method, we can instead use you can use the pipe function, and we apply it to the data frame. And inside that particular function, we set the first function, then dot the second pipe function, which is the second one. So it just creates a pipeline of operations, or different components or different functions that we apply to the DF data frame, and we store the result in DF transformed. Then we display the transformed data frame as shown. All right, pause the video and then work on the challenge. Right, moving on, we might want to group maybe data and have aggregate functions. So if we have this data set that we see here, we might want to create maybe a summary table and have and calculate maybe the total sales as well as the average price for each category. So we would first of all need to group the data frame by the category column that we see here, then apply our aggregate functions using the aggregate function, and it would take in a dictionary that has key value pairs. The key value, first one would be sales. That's the one that we want because we want to group the data by category and calculate the total sum. So that will we will call that column that will be created in that pivot table as sales, and the second one will be price, and we define the functions that we want to use to calculate the values, the respective values for each and every category for those columns. And then here we just rename the columns for just better understanding, so that our final data frame just comes out well. And we display the output here. By the way, the reason why we used sales here is because that's the name of the column that we are working with, but we want to have it total sales and maybe average sales. So we use the rename function for just renaming. Right, pause the video and then work on the challenge. Lastly, searching using contains. So sometimes you might want to search for records that contain a certain maybe character or text in respective column. So assuming we had this data set that contains information again about e-commerce products, and we wanted to maybe filter for records that contain the word smart in the product name. So we would first of all define our Boolean condition, our Boolean mask, which would be the following, the one that I've highlighted, and we would apply the contains function to the product name column. That's the column that we want to check for whether the word smart exists, and we pass the smart or the value that we want to search for in that particular column as the first argument in our contains function, and we set the case to be false, meaning that we can get any version of this. So if it's smart with lowercase, smart with capital, we'll still get those records. And yeah, so that's generally what we do, and here we just get the columns that we want to display. And you can see here we have records that contain just smart in the product name. Right, pause the video and then work on the challenge. All right, so that's it. So that's it with regards to this Pandas challenge. We hope that you are able to find some value in the learning experience. And if you did, be sure to give this video a thumbs up. And if you'd want to be informed when we post such future courses or future challenges or learning experiences, be sure to subscribe. Yeah, so the next challenge, day 27, I hope you have really appreciated the journey, and we'll continue. So we'll meet in day 27. All the best in your learning journey. Bye-bye.